Hello, this is Mr. Steinerson, and in this short video I'm going to go over how to interpret distance in time and velocity time graphs on a few exercises. I'll go through a few examples. Please pay special attention to the difference between the graphs and also the key points we'll go over in relation to direction and slope. As always, if you have any questions, please reach out and ask. Have a great one. Thanks.
For each of these examples, I'm going to be talking through different parts of the graph, explaining what happens in the motion, and going over some key ideas to help us process what this looks like on a lot of different graphs, whether they be position time or velocity time graphs. So in this case, when we take a look at the big ideas for position and time graphs, what we're going to want to focus on is how does slope impact and how is it part of the graph. And so in these cases, slope always refers to the speed. So a steeper slope will have a greater speed. So out of these two areas, C would actually be traveling faster over that interval of time because its slope is greater. And then when the slope is constant, the object is going at the same speed for that interval. Well, each of these, A, B, and C, all have constant slopes. So we know that there's a constant velocity from the beginning of this line to the end of A. There's also a constant velocity here. It just happens to be 0. The position isn't advancing or decreasing. And then C also has a constant velocity because it has a constant slope. All right, so how do we use the position time graph then to maybe answer what's really happening to the motion in each of these cases? So if we take a look at position A, for example, we know that the object is moving at a constant speed. So we can say constant speed, and the direction is away from the origin. So it's, if we put little tick marks in, maybe this is measuring out meters, we know that this might be 1, 2, 3, and so on meters away. So object A starts at 0 and it ends at about 5 meters away from where it started. So then we can move on and maybe take a look at section B. And section B, we kind of already talked about already, the position isn't changing over that interval of time. So this is simply stopped. Now, section C, what happens in section C is we start at maybe 5 meters, but then over that interval, we end up back at 0. So we're actually moving back towards where we started, and we're doing so at a faster rate. So it's constant speed still, and we could say it's toward the origin, and it's moving a little bit faster than the original one was. So we're going to take these key ideas and apply them to a lot of different graphs in this short mini lesson. Great, now we understand some of the basics of a position time graph. I'm going to take a look at one that has a curved shape. The easiest way to do this is think of a tangent line at 3 different spots. So I'm going to start at this point here. Let's call this point A. And then I'm going to do the same thing about halfway up the graph and the same thing kind of at the top of the graph to get kind of a general idea of what is happening to the motion. We know that because this is a position time graph, that slope is going to tell me the speed. So if we make a tangent line at different areas, we can compare the slope. So if I have the slope at this line, it looks pretty level, pretty flat almost, but then when I take it up to the middle spot, notice that that tangent, the slope has increased quite a bit. And if I go up to the very top, now that tangent up here is going to have a very steep slope. So I can tell that my position is moving away and my speed is increasing as the time increases. So in this case, I'm actually accelerating. And so I'm moving quickly away and I'm accelerating while I'm doing that. All right, so when I take a look at the motion of each one of these, this might be a little bit of a slow speed, this would be a medium speed, and this would be a fast speed when I'm taking a look at all these different ways that we're going along. All right, now that's important to kind of visualize because you might have segments of these graphs that have curves in them. A position time graph, a big key idea in any position time graph is it's always going to have a curve when accelerations happen. So if you see a curve, that equals an acceleration. All right, big key idea. All right, thanks. We're going to take a look at a couple more graphs, but this is a great idea to focus on for that curve position time graphs. Okay, once again, we're going to take a look at the curves of these graphs. And if you notice here, this graph is actually curved in the opposite way. And so once again, we can use that idea of a tangent. So at the beginning, I'm going to find a tangent and notice that the slope now is negative, and that slope stays negative, but it increases how negative it is as we go along the line. So I'm just testing this out, 3 different spots, 3 different tangents. I know my negative slope is increasing. All right, so I'm increasing in that negative slope. And what's happening in the position is I'm starting far away. So I'm starting at some position out here and I'm ending up back at 0. Okay, so what's happening to the velocity then, if we start at a lower slope, we're actually moving slow here, but we're going backwards, slowing towards. And then this is a medium pace, but we're still going toward. And then lastly, we're going faster and we're still going toward. So that sign is going to make a difference if we're positive or negative in terms of our slopes of our velocity. So another key idea here, if we have a positive slope for our velocity, in this case the tangent line, that equals moving away. And if we have a negative slope, it equals moving towards. Those signs don't really tell you if you're speeding up or slowing down. So we're going to talk a little bit more about that in the next slide. Okay, in this slide, we actually are switching gears. We're talking about velocity and time. And a key idea we talked about in the last slide is positive velocity, or the positive slope of that velocity would mean that we're moving away, and the negative would mean that we're moving towards. We're going to add marks on the velocity axis, and the farther we are from the origin, that means we're going faster. So if I put in some marks here, like let's say I have, these tick marks here like this, and I keep going away, as I increase, I'm getting faster. So this might be, 5 meters per second. The same is true though as we go into negative land. I'm just going in the opposite direction. So this might be a -5, but it's still increasing the rate of speed. The sign is just telling me the direction. So key idea there, we're going to come back to that in a little bit. So if I want to describe what's happening to the motion in A, B, C, and D, I have to now switch my mind to be thinking about velocity instead of position. So the farther this line is from the origin doesn't necessarily mean I moved farther from my start. It really just means I'm moving at a constant speed, and that constant speed is, in this case, maybe 5 meters per second. This section here, we're started at a constant speed throughout the whole interval of A, and then we're actually decreasing our speed. So if we start at 5, this might be 4, 3, 2, 1, all the way down to 0. So if I look at A and B, I know that this is a constant speed, and this is actually slowing down. And I'm slowing down, but I'm still positive, so I'm still moving away. All right, key idea here. So if you look at this, remember anytime we're on the positive side, we're moving away. This just means our speed is decreasing as we're moving away. Again, it's not like a position time. In a position time, we would be moving back towards our axis if we saw a shape like this. So train your brain to look at these keys first, and then think about those tick marks. What's happening to the speed? We're starting high, we're ending low. All right, in C, this is where we're actually stopped, okay? So we've reached a 0 velocity, so we've stopped here. And then in D, if we keep going down here, D starts now to change direction. We went from positives here and now we're into negatives, and we're increasing our speed. So we're speeding up, and we're doing so back toward our start. Okay, so we're actually increasing the speed. If we think tick marks, this might be 1, 2, 3, 4, 5, and the direction now is negative. That means we're moving back towards. This takes a while to kind of map your mind around, but keep practicing doing the interactives and doing the other practice in the unit, and come back to this video every time you need some of those key ideas as a refresher. All right, in this last example, I really want to tie some things together here. And so our key ideas to focus on are, as always, positive in a velocity time graph is away, negative is towards. We're going to add those marks on the axis. So I've done so already. And just as a review from before, we know that the object would be slowing down in A, stopped at B, and speeding up in C. So what I want to do is I want to show you kind of with this ball and this ramp of physics, what that would really look like. All right. And so if we were to kind of do this in real life, what would we see? So we have to first determine, where do we put the ball? Do we put it at next to the observer at the bottom of the ramp, or do we put it at the top of the ramp? Well, let's think what's happening. We know right away in the beginning, we're slowing down. So if the ball is at the top, we know that that would speed up, right? Because of gravity and its acceleration. So if we start with the ball in the bottom, and as it rolls up, it's going to roll faster in the beginning, but then it's going to kind of slow down and slow down and slow down until we get to a point where it is stopped, and then it's going to change direction and speed up, speed up, speed up, speed up back towards the observer. So that would give us an idea of this idea of slowing down away, where we have a positive velocity, stopped, changing direction, and then speeding up back toward the observer where the velocity is negative. Hopefully this makes sense. Please reach out if you have any questions along the way. Thanks.